Andreas was 6 years older, is 6 years older, and he was a very good skier too. So he sort of always had to fight up against his brother. But his dad already saw at the time that he, Alexander, would be the better skier, the more competitive skier, which wasn't obvious to him because he was so little. So today his brother is a banker and is also his manager, and he's a leader in the World Cup. Now that's not predictive using a lot of science and modeling. That's just intuitive predictive. These two, by the way, Alex and Michaela Schifrin, they're a couple. She is the all-time best skier, female skier. So what's the likelihood when they have children that they're good skiers? Not so difficult to predict. But what is the likelihood that one of their kids is a top football goalie? Well, with predictive capabilities and information about their genes, we could find out. Just as a little anecdote here, Alex is also a very good football player when he was little. So he made a choice to go into skiing. And I guess growing up in Norway helped. If he'd grown up in Spain, maybe he'd be playing for Real today. But it shows that the environment in which we have our genetics, we apply our genetics, also play a big role for how they're showing up. So predictive breeding has benefited from enormous advances in a couple of fields. One of which is just the understanding of the genome and the ability to basically analyze the gene. And the other one is to do with where the plants grow. They grow in the environment, not like us humans under a roof, they're exposed. So the ability to model the environment and that relationship is the other factor. So just looking at the genome, this is an example set of numbers from the human genome. 20 years ago, the cost to decipher the human genome was over $1 billion, and it took a decade. Today, you can do it in a day for less than $1,000. Surely you'll say humans are more complex than plants. Well, think again, wheat. The wheat genome is 5 times larger than the human genome. So it took until 2019 that the wheat genome was fully decoded. So that's one side, our progress on genomics. And the other side is the progress on environmental modeling and the ability for a predictive breeder to anticipate how his genetics will react in different environments. So I took an example. Just outside of Adelaide, you got York Peninsula, YP. It's a big agricultural area, barley, wheat, canola, pulses. So I asked our environmental modeling team, where on the planet is there an area that has similar environmental characteristics than YP? So they created this map. And you see the color coding. First of all, there's no place on Earth that's just the same as York Peninsula. You see the dark red color down at York, and there's no dark red anywhere else. You see some similar areas around South Africa, Argentina, and also in the Northern Hemisphere. By the way, we call this the Shazam of climate. So just like Shazam, that's the app which when you basically listen to a song, within 10 or 20 seconds, it tells you what song you listen to. It's the same capability. You're looking to, in this case, fragments, segments of temperature, humidity, precipitation, and you compare that with billions of data that we have over several decades across the world, and you get a map like this. So the place that I thought was most interesting, which is not quite like YP, but quite similar, is the island of Mallorca, the home of Rafael Nadal. And I don't know if you've been to Mallorca. It looks like this. It's an island in the Mediterranean, south of Spain. They grow wheat, a little smaller than YP. But according to the data, very, very similar climate. This is really important for our breeders when they do predictive breeding. So they're able to say where is the environment that either comes closest or how is it different to what I'm using for. It's also important, by the way, for growers. Just another small story. On Tuesday, I was out at Mount Barker on a big Brussels sprouts farm, and the farmer said to us, Scott. He said, I get all my genetics from Holland, and they tell me what they do, and then I have to plant them here, and they do something different. Well, it's not Mallorca, right? So there's no Brussels sprouts grown on Mallorca, but where they are grown in Holland, the climate's quite a bit different. So there's no surprise that they show up quite differently where he grows them here. Now, we all know this predictive capability. I suppose most of you are probably consumers of Netflix, and when you watch Netflix, you get this, you watch this, therefore you also like this. That's the same data science behind it. So the equivalent would be, you performed well on York Peninsula, you're also likely to perform well in the following areas. Really important capability for our breeding process. So let me come to the third, of breeding 4.0, the third of the three examples. Prescriptive breeding, the most complex, and one where we're literally just at the point where we're crossing into it, because it needs a lot of information, a lot of modeling capabilities that don't all exist today. Basically, there's 3 steps to it. The first step is you're prescribing a phenotype that doesn't exist today. You're looking for something to create that doesn't exist today. So you cannot rely on a real plant that you can analyze. So firstly, you have to model in silico, in your computer, what that target looks like and how the respective genotype would look like. Then you have a next step where basically based on the genetics that exist today, which steps would you have to go through to get to your target genotype? Again, you do all of that in a computer. And the third step, you start from a real plant. What crossing steps, what gene editing steps do we have to go through to get to that target phenotype? So quite complex, as you can see here. Again, we know this a bit, again from Netflix, and this is the Netflix originals. So based on more than 200 million users of Netflix, Netflix is able to say exactly what you watch, where you pause, where you repeat, what you enjoy, what you see several times, and they created their original movies on the basis of that. That's prescriptive, in this case, filmmaking. You know, think about a film like Squid Game. I think 1.4 billion hours watched across the world. Quite unique. So I was thinking, how do I bring that to life? No more sports analogies here. And the example I came up with, I call it Passengers meets Avatar. So imagine we discover a planet far away, it takes 300 years to get there, which is habitable, but is different than Earth. So you have to have different capabilities, different characteristics to be able to live there. So let's assume you have to look like this. So the prescriptive breeder has the task now to decide what's the crew he puts on board of that spaceship, and what are the instructions, who with whom, over 10, 20 generations, so that you arrive with the crew that can survive on that new planet 300 years later. That's what we do with prescriptive breeding. So what is this all going to help us to do better and faster in the future? The data scientists call this use cases. I think it's a lot more elementary in modern plant breeding. Well, we can accelerate yield gain. We can adapt genetics to climate change, anticipating what's going to happen. We can fight diseases. So we can overall reduce the environmental footprint. All topics you've been hearing throughout the conference. So a couple of years ago, the World Resource Institute came up with a landmark report that basically showed the role of agriculture in the next 30 years until 2050 and what can help to reduce, to get to a 1.5 degree target. One of the most impressive analyses I found was if we take productivity as it is today and anticipate the population growth and the dietary change, we would need 600 million hectares more land, and we can only afford 0. That's the land gap that you see here on the slide. The only way to close that land gap is to continue to raise productivity, in fact, accelerate that productivity growth beyond what we've been achieving over the last couple of years. So we'll need breeding that's faster and better than what we've had in the past. So climate change, a lot of has been talked about climate change. This is a simulation over the next 100 years. In the worst case, so this is not the 1.5 degree scenario, thank God, of how temperatures will rise across the world and will shift across the world. Our job as modern plant breeders is to anticipate, even if the change is not quite as stark as here, and create genetics that will perform wherever the crops are being grown in the future on the basis of those changes. Fighting diseases. So we all have had our experience with viruses. Plants have too. This is an example for a disease called tomato yellow leaf curl virus. It's quite devastating for the plant. It basically eradicates the tomato. We're able to use modern breeding and it's transmitted by an insect. So we're able to use modern breeding to make the plant more resistant to that insect and therefore basically help protect it, if you want, stimulate its own self-defenses. We'll see more of that as the climate change, as new diseases, new pests will arrive in places where there isn't any natural resistance. And the last example is an example of how we reduce the impact on the environment. And think about the food we're eating. So the top here shows sort of the traditional value chain, from seeds to feed crops to animals to food. At the bottom is what the future value chain could look like. And literally, we're just at the beginning when you look at some of those products that you can buy today. We need to understand animal genetics. We then have to create new seeds for new food crops that don't exist today with the characteristics that we want that then become our food and at a much lower greenhouse gas emission footprint than that traditional value chain. So those are just 4 pretty fundamental examples of why we need modern plant breeding and why we need to accelerate the benefits and the progress. So to close, I've used the most fun prescriptive app that's currently available on the web, and that's ChatGPT. And I asked ChatGPT, literally that's what I asked, write the closing speech for a presentation about modern plant breeding. Let me show you what she came up with.
Thank you all for your time and attention. I hope I have been able to show you how modern plant breeding can be used to create healthier, more productive, and more sustainable food systems. From developing drought-resistant crops to developing crops that are better able to resist pests and diseases, modern plant breeding is an essential tool for improving food security and nutrition for the future. I hope that you have been inspired to think about the potential of modern plant breeding and how it can be used to create a more sustainable and secure world.
So it was that moment when I thought, I should have asked her to do the whole thing. So I added this, let's help humanity grow. Thank you very much.